All right, No Shave November continues. I can see that y'all are not participating, apparently. All right. Mas Barba? No?
Go back.
Yes. Now check it out. This applies to this, right? PEMDAS, when you have an exponent. Now, what's 4 to the third power? 4 times 4 times 4. It's not 12.
16. That do it like 16.
What is it?
16.
It's not,
It
no.
is 16.
No, not 4 times 3. 4 times 4 times 4.
Wait, 4 times 4 times 4?
Yeah, 4 times 4 is 16 times 4.
Oh, it's
So 64.
32.
64. 64. 64. 64. Not 67, 64. Now look. But look, this sign is negative. No. It's not negative 64. It's 64, but is it going to go on the top or the bottom?
Bottom.
Since it's a negative exponent, it goes to the bottom. Okay. Now, negative 3 times no exponent.
You're not right.
Negative 3 times 1. I mean, I am, but you can't see it. Invisible ink. Now, check it out. Negative 3 times 1 is a to the negative 3. And then times
Okay, so like,
a to the negative 4. Okay. Now, we're not done here. Man, just do it. Go. There's one right here, too. Now, we're not done because, look, I have the same base being multiplied. So what do I do with these numbers here? We have to add them up. What's negative 3 plus negative 4? No.
wait,
Negative 7, right? So it equals a to the negative 7 over 64, right? Now, can I leave a negative exponent? No, it has. No, you can't. It has to go to the bottom. So if there's nothing left on top, you put 1 on top. 64 goes here. And then a to the 7 right here. Yeah, the a negative 7 goes down to the bottom at the positive 7.
Well, I don't know how you went from that to 164, 87.
Okay, when this goes to the bottom, when there's nothing left, you got to put a 1 up.
No, but so where you get 64 from?
Okay, what's 4 times 4 times 4? 4 to the third power.
Yeah.
We said it was 64.
Uh-huh.
And then since it's a negative exponent, it has to go to the bottom, not the top.
So what I'm getting here is getting if the number is getting like multiplied by an exponent, it's going to the bottom. But if it's not getting multiplied by an exponent, so if it's a negative number, it should still be on top.
A regular number to a negative exponent has to go to the bottom of the fraction. Yes. Good questions.
I got you.
Y'all are locked in today. Wow.
Yeah.
I wonder why. All right, so make sure you got that written down. Did you turn in last week?
This there.
And
I heard that.
what did I just hear?
Right now, right now.
No. Oh my goodness. That's crazy. Now, did any of y'all need hours?
Always for what?
Too many hours?
This is a free
I've
food.
never asked them.
Okay. Anybody?
No.
Okay, there's 2 for 1 hours Wednesdays after school. Call attention. Double the hours.
Got you.
But how do they keep the attention, man?
Whatever. Hey, Loki.
But that's a healthy budget.
It is, right?
Sir, you like the teacher of the year.
You say plug.
Yeah.
Whoa.
Oh, that's a good thing.
Why would you say that?
Oh, it's like a black thing, you know?
Like a what?
It's like a black.
What?
You call me what?
So I gotta use advanced terminology.
Oh,
You don't have to do that, man.
advanced terminology.
All right. So, W assist. There you go. Yeah, teacher of the year. Don't forget.
Yes, sir.
Raining.
When?
I reign because no one has beat me in a cage match, you know?
It's raining.
Sir probably has some.
Hey, wait. Didn't the Spurs lose to. Who did they lose to? Wasn't that the Suns? They lost to the Suns? We won the last 2 games, didn't we? Oh, no, that was the Stars. We won against the Wizards. The one-win Wizards. We didn't lose. Hey, we didn't lose. I know, but we didn't lose to the worst team. So we're not the worst team.
Actually,
We're like second or third to worst. Okay, we're getting better. Hopefully. All right, we'll see. Yeah, and Anthony Davis, he'll be healthy for a few games, maybe 6, 7 games, maybe, and then he'll get hurt again.
so what are we doing today?
Great question, Mr. Locked In. Here we go. We're doing exponential functions, my guy. All right, y'all ready to did I pass it out to you yet? I guess I should do that, right? Sorry, I was just I'm playing y'all. Locked in, go.
So we need Desmos, sir?
You do need Desmos, and you don't need YouTube.
Nah, I'm not.
We
I'm not.
need
I cannot. No, I already watched YouTube during 4 period because my teacher wasn't there. So, I'm good, right?
Y'all do that something?
Yeah, she was cool. So like,
What are you
I
saying?
did it, I
What are you
was
saying
in-
about me?
not so, but like I never knocked you.
I know. Every day you do. Oh, but for real, every day. Write this down. Exponential functions. All right, when you have an exponential function, it's y equals a times b.
Exponential thingy just the
Oh, you repeat the thing.
Well, what it is when you have a little x in the exponent. So instead of x being a big number or a big base, it's going to be a small exponent up top.
Oh.
All right. So y equals a times b to the x. Okay, now if b, the second number, the base, okay, b is the base.
So like, if the B is eating the one, is decreasing, right?
Wait, what?
Is that what you're saying, sir?
If b is greater than 1. So that's what this little like greater than sign means.
That's the thing.
Look, don't scream all at once. I'm moving it. So if the b is great, we're gonna write it down. It's gonna be all right. If b is greater than 1, okay, that's called exponential growth. Exponential growth. Now, which way does exponential growth go? It goes up to the right. Up to the right. Okay. Technically, it's not straight, it's curved like that. So that means it is increasing. Well, they're both going to the right, but are they going upright or downright? Okay, now, please notice what this means. If b is in between 0 and 1, what kind of numbers are between 0 and 1? Decimals and fraction. Right, but think of a number between 0 and 1. What's a number between 0 and 1? 0.5, 1 over 3, 0.7, 2 over 5, 0.67, 0.6 repeating 7, right? Okay, so if it's less than 1, but not negative, so between 0 and 1, that is called exponential. What's the opposite of growth? Decay. Like when you watch Mind Rot all day long. Doom scrolling. Oh yeah, brain rot, my bad. It goes like this. See how it's like, what?
Decay? Is that decay?
No, it's decay. What are you talking about? I don't know what you're talking about. Exponential decay is going down to the right.
So it's always going to the right.
Right.
From this one.
I mean, like, technically it goes left too, but as it goes to the right, it's either going up, or as it goes to the right, it's going down. And instead of increasing, that would be a decreasing function. No, I'm actually really sick. Like, very contagious.
So
You save your sick days for when you're feeling good, you know?
You're right.
Right?
Yeah, that's low-key the method.
Like, that's high key. What would you say earlier?
Low-key the method.
No, you said something else.
I think you said low-key the method.
I don't know. You said something.
Not.
It's something. We'll have to think about it. A line. So an asymptote. Now, asymptote. Asymptote. Like the P is silent.
What's the point of putting letters?
Like pterodactyl.
Is it just like the word
Probably. It'd be a letter count, but asymptote is a line which the graph gets close to. You know, if I say, hey, y'all, don't do this, and y'all like get like, all right, well, I'm going to do like almost that, you know. Y'all know how it is. But never crossing the line, you know? Never touches or crosses the line.
Wait, is it? This was that like this one weird circle where the light like never touches and you go.
Something like that. So on these little pictures here, see how I have a dashed line that it doesn't touch? It like it gets closer and closer, but it never touches, right? Here's an example. What's half of 2? What's half of 1? What's half of 0.5? You keep going and going and going. Is it ever going to get to 0?
Could.
No, it will never get 0. No, it could not. I'm sure, because you cannot double 0 and have a finite number. It's literally nothing. So if you're cutting in half, you're still cutting something, and it's still something. It just gets smaller and infinitely smaller. Yes. Okay, ready? Oh, okay. Well, get ready. We're going to graph. So we're going to rewrite the equation. Y equals 2 to the power of x. 2 with a little x in the exponent. On Desmos, can you type that in? Y equals 2. That's the easy part. How do you get a little x in the exponent?
Do you click B and then that X, I think?
One way to do it is to click this keyboard and click this little A to the B. Who knows? Now, once you graph, now you have some points here, right? You can click the y-intercept. Now, is this going, as it goes to the right, is it going up or down? And it's positive, so it is growth, right? Now, y'all see that y-intercept is 0, 1? Put a point at 0, 1.
I think this one's easier.
It's the same questions for a different function. So I'm going to show you the answers. Ready? Domain. Do you see how it goes to the left forever? If you keep going to the left, it's never going to end. It's never going to end if you go to the right. So what do you call it when it's all of those numbers? All real numbers. Yes. So domain, all real numbers, is that weird R.
That's really cool, bro. I guess during this time, it's not good to cough in your hand. Cough like.
Handshake?
No.
All right. Now, what's the range? Now, this is where it gets crazy. Do y'all see how this flattens out right here? Okay. So that's what's the asymptote. Okay. So think of an imaginary horizontal line.
So
What?
that's not.
No, it's not. You could zoom in and it wouldn't be touching. You want me to show you?
Yeah.
All right. So see where it looks like it's touching? Watch me zoom in.
It looks like.
Yeah, it does, right?
I don't know.
Oh, look at that. Exposed. Right? Okay, now how do I get out of this?
Just like cancel that.
Oh, there we go. There
delete
you go.
the
You click the home button and it takes you back home. All right. Now, since it flattens out at 0, you'll see 0 on the y-axis. You call that y equals 0 because it hits the y-axis at 0. So go ahead and put a dashed line on 0. It's kind of hard to see, but I'm making a dashed line on the x-axis.
So like, let's say if the line is hitting 1, it'll be 1, right?
Okay,
Like
so,
one.
so
like
if you looked at this, you see how this is flattening out at 1? Then you would say y equals 1. But you could tell because there'd be a number right here. Nothing's happening. Now, what's the range? Here's my question. Does it go below 0? No. So your range is the y values greater than 0. Above 0. Wake up. Hey, you. So you're going to put greater than 0. Should we underline it? And the answer is no. It never touches 0. Hey, it's never equal. It's only greater than 0. And then what is my y-intercept? That's the first thing I noticed. Hold on. The first thing I noticed was this y-intercept. You can click it. It's 0, 1. And here's what you're going to do. You're just going to sketch through that 1 without touching the 0. Okay? So you're like, okay. Now, if you wanted to hit the gear and hit the table, you could plot some actual legit points. 0, 1, 1, 2, 2, 4. Oh, okay. That's cool. Oh, no. You can do whatever you want. Oh, no, it's cool. So when I hit the gear, the points I have are 0, 1, 2, 1, 2, 4. If I plot those 3 points, I'll make a nice, sweet looking exponential. Yeah. So guess what? On your assignment, you should actually graph it like I'm showing you, right? Instead of sleeping. Hey. Literally. Quite literally. It is. You know, every day is this column. Just like you watch YouTube instead. That's crazy. All right, ready?
Yeah.
Or not? We're gonna do. Well, I'm gonna show you number 2 and then one on the back, and that's it. All right, number 2. Excuse you. 1/4 x. What did you just say? Whoa. Oh my goodness. 1/4 x. All right, here we go. Ready? So y equals parentheses 1 divided by 4 parentheses.
The domain is definitely.
It definitely is.
Is it?
I'll tell you, it's always going to be all real numbers for the domain. Always. Yep. That's why it's literally everything. All right, now, when I graphed it, what's my y-intercept? 0, 1. Click, bro. Click.
Who are you talking to, bro?
So y-intercept is 0, 1. I know the domain is all real numbers. What is it? Growth or decay? As you go to the right, is it going down or up?
That's a decay, sir.
Decay. Wake up! You head up. Head up. All right. So it is decay because it's going down to the right. I could do my little, table.
Do we need a table?
Do you need it?
That's
I mean,
necessary.
you could.
Oh, we don't. Okay, so we don't need it. Let's go.
I mean,
No, like
if you don't want to pass.
no, but like,
No.
no, but like, do we actually need a table?
4, 1. I mean,
No, like for real. So like,
I guess we'll never know. I'm showing you to do it with the table, so that should be your key. -1, 1, 2, 3, 4. 0, 1. 1, 0.25 is close. Now, do you see how it levels out at 0 on the y-axis?
Yeah.
So draw a dashed line on 0. That's the range is always y equals. The question is what number, and it goes through 0. And then sketch that going down and flattening out without touching it. Wait, whoops. What's wrong? What? The range is not done yet. Let's do the range. I'm glad you said that. So why is it going to be, is it above or below 0? Above.
No.
So it's going to be greater than 0.
Also, if wait.
Yeah, because it never touches the.
Yeah, like,
no,
but like, if it's above 0, it's always gonna be
Greater.
It never touches the x-axis, so it's never equal to 0.
So if it's below 0, it's gonna
Maybe less than. All right, let's pick one on the back. All right, we can do 5.
I mean,
I think we should do 6. It's got all the good stuff.
so let's do 6.
But we could.
I mean, is 5 easy?
Same idea.
So like, this is a hard one.
So the thing you need to know is what do you do if there's a plus minus number after it? So that's why we got to try 3, 4, or 5. 3, 4, or 6 is ones we want to try. Let's just do 6. Let's do the craziest one so you see how crazy it is. All right. If you want to know the other ones, I'll give you the answers. I'm just saying, like, the one I'm going to show you is number 6, and then we'll go back. Y equals 5 times 1/2 power of x minus 3. This minus 3 is very important.
What is that? Like if it shifts or
Yeah, it does shift. Up, down, left, or right. What do you think?
So like what?
Okay, look.
So like, oh okay, I got you. So like the -3 determines if it's
if it goes
greater
up or down.
Yeah, like yeah.
Up or down. Yeah, it's called a vertical translation. Vertical shift. Wake up. Wake up. All right, now, is it growth or decay? As it goes to the right, it's going down because this is less than 1. That's another way to tell. Less than 1 is decay. Domain is always all real numbers. Range, now hold up. It goes past 0 this time.
Yeah.
Where does it flatten out? What number is that?
3. No, -3. Negative.
Ah, it's this number right here, right? Ah, so the range is it above,
Negative.
greater or less?
Less.
It goes up from -3, right?
Oh,
Above -3 is y is greater than -3. The y-intercept touches right here at 0, 2. And what is that asymptote? Where does it touch? Where does it flatten out? Y equals -3. Now I want you to notice the range and the asymptote are always going to be similar, but the range is an inequality. The asymptote is an equals. See the difference? Wake up! Wake up! Hey!
feels like it's gonna get
Okay, so but like what about that 5? What is that 5 company?
I'll show you. So
Yeah.
first of all, let's draw this horizontal line at -3. 1, 2, 3. Go ahead and put dash, dash, dash. Never.
I guess that's just a
I'm always peak.
too much.
Probably. Now check it out. You can just plot some of these. -1, 7. -1, 1, 2, 3, 4, 5, 6, 7. Okay. And then what are you going to do? You can just draw these 2 points and then flatten out right there. That's good enough. Is what it is. So what the 5 does is it vertically stretches it. So it makes it like this.
The 5.
Okay.
It's not your stare or so.
All these basics. You're basic. You're not basic to me. You're special.
So,
All right.
well, they're like pretty.
All right. That's it. Y'all good with this? It's whatever. Yeah. No, you can't. There's that. Now the only thing I would write different on here is I would put all real numbers as that weird R, right? Get that down. I'm gonna give you the assignment, but you got the rest of today and tomorrow to finish it. So no one's gonna complain, right? Wow. Wow.